Hello, everyone. Thank you for having me here. My presentation today is about fuzzy approach that tackles crucial task of identity resolution for law enforcement agencies to identify the real identity of a suspect out of false identities. Today's presentation will be in the following format, starting with introduction, going to problem definition, then discussing the methodology, and discussing some experimental results, and then the conclusion. What is this research about? In big data, it's very difficult task for law enforcement agencies to match the real world identities. And with the passage of time, the data increases and it becomes more and more difficult task for them to match the identities, especially when there is a missing information or incorrect information. But what is identity? Identity is a property or characteristics of an entity that differentiate one entity from another. And each entity has its attributes that can be used to identify the entity. Fuzzy matching is a technique to do the string matching, and the most common technique is added distance. But added distance normally fails when strings are written in short format or in abbreviated format. The other technique is the Joro distance that compares the short strings, such as first name or surname, um, but it fails if there is a positional difference in two strings, and that normally happens in the long names. In 1990, Winkler enhanced the algorithm and added the prefix higher weighting to the name, but the problem remains the same that with the longer name, when there is a positional difference, the algorithm failed and it doesn't match the two strings. In previous works, our researches, majority method utilizes one similarity techniques, and most of them are rule-based. And if they do the scoring on the attributes, they at the end combine all the scores of a record as one. That requires a huge computing power, and the results are very slow. And the rule-based techniques are time-consuming and requires a human expert to write rules for different scenarios. In the recent research that utilizes rule and graph-based approach to score the attributes and then analyzes the link between identities using a graph-based method. Um, this fuzzy approach has carried forward the same approach in an unsupervised manner using different similarity techniques. So what is the problem? Um, the main problem in the big data is the quality of data, and then it could be a missing or incomplete information, and that can lead to difficult record matching or deduplication of the data or of the records. Previous researches, as they does not utilize the combination of string similarity techniques, and then because each similarity technique is a domain specific and can perform very well under a specific scenario. So using one similarity technique will not provide a better results. So it's better to use the combination of similarity techniques. Um, so previous approaches do not consider followings to use different similarity techniques and use them at different stages, and then use the clustering technique with help of segmentation and graph analysis. Methodology. For this fuzzy approach, in the methodology, a criminal data set has been used that has been anonymized. Um, By looking at the data set, there are more than 6,000 individuals that have two or more similar nominal reference numbers. So we can say that we can refer that to as an ID number. And then there are 309,000 records that were searched based on the surname and full name and the date of birth that are duplicates. So in the methodology, the similarity techniques have been used in the cascaded manner to generate the score of the name. Soundex and Jauregg-Winkler algorithms were used to do the scoring, and then these two scores of Soundex and the Jauregg-Winkler were added to generate the aggregated score. The other attributes like ethnicity and address attributes were scored using the added distance. And then the clustering technique were used to group the similar records. Then segmentation process were applied to extract the similar records from the clusters and then do the graph analysis. In the methodology, the data pre-processing is something that to eliminate the missing value from the data set so the methodology can work. The information, the records with missing values were removed and then from the actual data set, and then nearly 715,000 records were with complete information. And that's the data set where the methodology has been applied on. And within the data set, the address field was combination of 3 or 4 different fields. And all those three fields were combined into one. And then the text was converted into a lowercase. Step where we have to do the string matching and generate the aggregate score. The Soundex algorithm was modified from 4-digit code to a 6-digit code, where the first character of the name from the Soundex code was removed to form the 6-digit numerical code. And then the Jauregg-Winkler algorithm was applied on this code to generate the Soundex score. And same Jauregg-Winkler technique was used on the name to generate the Jauregg-Winkler score for the same name. Then to generate the aggregate score, the Jauregg-Winkler score and the Soundex score were combined, were added and divided by the average to give us the aggregated score. When the searching and matching criteria had to begin, the main aim was to eliminate the most of the non-match entities during the initial search. And the search is in the iterative process. And it takes three different name variation as an input. The matching of the attributes are done by exact match or added distance match. So genders were done by exact match, while the ethnicity and address fields were scored using the added distance to generate the scoring for those attributes. At this stage, all the duplicate records removed, and then it was make sure that low aggregated score records were even retrieved. Then once the final data set is there with the low aggregated score, that has been fed into the clustering algorithm to using the mean shift clustering to determine the number of clusters automatically based on the number of records. And then records were matched and compared to create the segments of records. These segments were part of similar records that were linked together from the different clusters. And then the highest address scores were extracted from the segments of the record from the dataset that were obtained from the clustered dataset. So after retrieving the similar records, they were merged into one dataset, while the records which were not matching the address or name, they were kept into a completely separate dataset. In the graph analysis, the segmented records are compared with the clustered record. So to generate the first graph, because the graph analysis is a layer-based approach, so in the graph analysis, the first graph was created using the name and the cluster labels. That's kind of like a normal visualizing the clusters and the name available in those clusters. And the second graph was created using the name and the segmented data set. So so the name that are linked with the different addresses. And then the third step was to compare the both graphs to find the matched identity out of the all entities were or false identities were retrieved. So coming to our experiment, it was assumed that the investigation officer is working on two different cases at the same time and have a very limited or minimal information about the suspect. And when the investigation officer has input all the name variations, the gender, the ethnicity, and the address, the partial address, into the algorithm, the first case retrieved 95 records for the first name variation, for the second variation 61, and for third variation is 95 records. And the total records when they were merged and removed all the duplicates, it was 173. And similarly for the second case, where 41 records were retrieved, but the resultant data set was 52 records, removing all the duplicates from it. When the clustering done for these 173 records for first case, it generated 4 clusters. And during the segmentation process, the highest score address, which was 83, was picked and went through the cluster records for the matching score or address scores to retrieve about 16 records that has similar name, two different address, date of birth, and some different addresses. In the second case, 52 records were retrieved, where the records were grouped into 5 clusters. The segmentation process picked the highest score of the address, which was 1, and during the segmentation process, matching all the records with the cluster data set, it retrieved 22 records of the same name, 3 different date of births, and different addresses. So for the first record, when the graph analysis were done in a layer-based approach, the first graph was created using the cluster and the name, and the second graph was created for the name and the segmented data set. Then when the both graphs were combined, it produced a third graph which identified the name of the suspect which it was desired. And then for the second record, similar thing happened. So the graph was layer-based approach, and then by comparing or analyzing the two graphs or merging the two graphs, the suspect identity was identified with a link to 2 different addresses here. So it's by looking at the results, it is evident that this approach is quite handy for the law enforcement agencies to identify the suspect identity and match it with a real identity easily with the minimal information available. It doesn't mean that it has to have quite a lot of information, but it can increase the investigation process. And if in future, if this approach can be improved by introducing a weighting system for each scored attribute, that will definitely help. And then adding the knowledge base to the approach will also help that when the initial search has been done, then all these results can be saved into the knowledge base. So next time in future, if the search has to be done, then all that identity matching can be done in knowledge base fast, and then into an actual data set, which can help the whole search process faster, and it can simplifies the process as well. This is something, the list of references that I have used in the presentation today. And thank you very much for listening to me today. And now I would really appreciate if you have any questions related to my research.